Okay, guys, you don't want test review. I'm just going to kind of blaze through this pretty quick, just so you know. You can slow it down if you want, and rewatch. The image shown will be reflected over the x-axis. I'm going to label that for the actual test. Will the x values and y values of the image's vertices be positive or negative? So as it reflects, it's going to show up in quadrant 1 here, roughly like that. It's not perfect, but it's good enough for what we're doing here. When it talks about the vertices, it's talking about the corners of the shape, right? And so the vertices in this quadrant are going to be positive and negative. The x value will be positive, the y value will be negative. When we shift up into quadrant 1, the x values will be positive and the y values will be positive. So we would say something like x values will be positive, the y values will be negative. Obviously, you'll write out the full word, right, when you do this, right, when you need to do that. But as long as you understand that whatever quadrant it's going to be in, it's talking about the negatives and positives versus the x versus the y, right? So that's the idea here. Triangle ABC is shown. Write an equation that can be used to determine the value of x. Well, we know that these three angles will add up to 180, so I'm going to do that 5 times x plus 2 plus 3x plus 8 plus 90 is going to equal 180. Okay, so boom. First one right there. Show our work. And we write 5 times x plus 2 plus 3x plus 8 plus 90 equals 180. I'm going to distribute first, so that gives us 5x plus 10 plus 3x plus 8. So just get rid of the parentheses there. Don't need them. Now I'm going to combine like terms. Right? These have x's, so I can combine them to become 8x. And 10 plus 8 plus 90. It's going to give me 18 plus 90 should be 108. Let's see. 10 plus 8 plus 90. 10, 8, 90. Just double check. 8. That's 10. Boom, there you go. So 8x plus 108 equals 180. We'll subtract that 108 because that's the inverse right there. Inverse of addition is subtraction, or the opposite. That's going to give us, let's do 180 minus 108. We're going to have to borrow, make that a 7. 10 minus 8 is 2. 7 minus 0 is 7. And 1 minus 1 is 0. So that gets us 8x equals 72. Now we're going to divide by 8 because we have multiplication. The inverse of that, or opposite, is division. So that's going to give us an x value of 9. So I have my work right here. I have my value of x right here. So I've got those first three bullets. So I've got 3 out of 4 points on the test. Please organize your work like this. So it's super easy for whoever's grading this to be able to grade it quickly, right? So give the measure of BAC. We look for the letter in the middle. So that BAC is going to correspond to angle A here. So we're looking for the measure of that angle. So the idea is we're going to take that 9 and we're going to plug it in for that x. So it's going to become 5 times 9 plus 2. Sorry. PEMDAS, right, we're going to do the parentheses first. So 9 plus 2 is 11. So it becomes 5 times 11, which is 55 degrees. So that's our measure of angle BAC. BAC is equal to 55 degrees. And so we got 1, 2, 3, 4 points right there. Okay. Triangle DEF will be rotated in the clockwise direction about the origin to form triangle D prime, E prime, F prime, determine the location of E prime. So 90 degrees clockwise will end up in quadrant 2 right here. I'm just going to do some patty paper. D, E, F. I'm going to put it on the back. Excuse me, guys. Sorry about that. So put it on the back, put it on the front. Now I'm going to rotate it 90 degrees counterclockwise. Line it up here. So it's going to be This is all on here, right? Yeah, okay. Okay, so I got it right there. D is right here, so that's going to be D prime. And then E prime is down here, and the F prime is right here. Use a protractor to make sure we have straight edges here. Okay, so I've got it right here. We're looking for E prime. That's going to be 3, -5. The other way to do this, right, is to take a look at E. It's at 5, 3. Okay, and for a 90-degree rotation, right, you're going to flip your X and Y and kind of match them to whichever quadrant you're in, right? So you flip them, keep the first one as positive, the second one as negative, just like that, okay? 3 relationships are shown below. Only one is proportional. Identify it, explain how you arrived at your answer, provide an equation that models this relationship, and select a table that does not show a proportional relationship, and show evidence that explains why it is not proportional. So what I do here typically is look at the pattern for my x's and the pattern for my y's. So my x's are going up by 1, my y's are going up by 2. If I reverse it, I want to get to 0 for my x's, and if I reverse it here, I get 0, 2, which is not proportional because I want a 0, 0 here. When I do it like this, these are going up by 2's here, and these are going up by 4's. Okay. When I reverse it, I subtract 2 here to get to 0. I subtract 4 here to get to 0. Boom, that's proportional right there. But I'm going to do the last one here, going up by 3's for my x's. And then I'm like going up by 2 and then by 4. So plus 2 plus 4 plus 8. So I'm actually doubling these. So rather than adding 2, 4, 8, 16, I'm actually multiplying it by 2 each time. But what that means is this is not proportional, because when I reverse it, I get 0 here and I get 1 here. So I've got identify this relationship. I'm going to say relationship B is proportional. Okay. Explain how you arrived at your answer. If I were to graph it, for instance, where do I have graph paper? All right, you'll have graph paper on the test, guys. I should have given you a little graph. Ooh, I'm going to add a graph to this, I think. Okay, so I'm going to put 2, 4, 4, 8, so 5, 6, 7, 8 right there. And I reverse it, I can see that it's going to go through 0, 0 right there, right? Okay, so there are multiple ways to talk about this, right? You could also say that y is double x, x is half of y, and it kind of holds true for each one. But I'm going to say that when graphed, B goes through the origin. The origin. Okay, provide an equation. Well, if I look at it in terms of y, I could say that y is equal to 2 times x, right? So I take all my x values and I multiply them by 2 to get to y. Right? 6 times 2 is 12, 8 times 2 is 16, etc. Or I could look at it in terms of x, and I could say x is half of y, like that. Those would both work. There are some other variations here. Select a table that does not show proportionality. Show evidence that explains why it does not. You could say A or C, and I would use the same one, right? A is not proportional. Let's actually go to a different reason than I'm graphing it. Okay, A is not proportional because when you multiply x, the multiplier doesn't hold true, right? So like when I look at y and I take a look at x, right? If I take x and I multiply by 4 to get there, right? 2 times 4 is 8, 3 times 4 is 12, right? So we could say something like the pattern doesn't hold true for x, so we'll say, let's actually do a comma, and we'll say, because when you multiply x by 4, you don't get the same answer for your y's, for your y values, right? You could also graph it and see that it passes through 0, 0, or that it doesn't pass through 0, 0, it passes through 0, 2, but there's a couple different ways you could answer that. Similar to C, right? Your pattern doesn't hold true for your y's. Yeah, okay. Following is ridge transformation. Please refer to the questions below. Well, we can see that it's not rotating or reflecting, so it's a translation. Okay, it's congruent. I can just look at them and tell that. And it's not a reflection or a rotation. Again, you would write these words out fully. What is the rule for this one? Well, this is my pre-image here, and this is my image. I'm going to go from K to K prime. I'm going to go left 2, and then down 1, 2, 3, 4. So you'd say translation, 2 left, 4 down, something like that. Okay. If square ABCD is rotated around the origin to form their A prime, B prime, C prime, D prime, would they be the same size, smaller, or larger? They would be the same size because rotations are rigid transformations, which means they're congruent. Would they have the same coordinates? Well, no. When we talk about this, right, as you shift to different coordinates, your signs are going to be like different for each different quadrant that you're going to be into. So it will not have the same coordinates. No. Would they be congruent? Yes. How would you know? Rotations are rigid transformations. Okay. All right, number 7, two different transformations. Take x, y, z to equal x prime, y prime, z prime. So the first one is a reflection over the x and the y. Or y and then x. And then the second one is a 180-degree rotation. Okay. Number 8, I'm going to move through this pretty quick because I'd like to get out of here. What is the transformation that correctly proves that these are congruent? I can see that it's kind of like this one. This one is kind of like stood up as it rotates, right? Or as it moves. So we could call that a rotation. Now it's going over one quadrant right there. We could say it's a rotation. It's 90-degree clockwise. But what's going to happen there is it's actually going to put it here, 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 and here. You could do that as a rotation, right, with tracing paper. Okay. It would rotate right there. So that's not all you need, right? At that point, what you're going to do is you're going to translate one right and then one up. Sorry, actually, hold on. One right and then one up. There you go. Boom. So you will translate one up, one right. Translate it to the right by 5 and down by 4. You could use patty paper for this or just do count on the grid. So I'll start with L, go right by 5. 1, 2, 3, 4, 5, and then down 4. 1, 2, 3, 4. L prime, and then M is basically 2 away. And then down 4 and 1. 1, 2, 3, 4. Right. You could also actually translate them, right? Go right 5 and then down 4. But that's gonna be like that. And then M prime is right here. It's gonna be 1, 1. So you just gotta figure out where that particular one is. In the diagram below, the measure of angle C is 59. Determine the measure of angle F. So we're looking for this right here. Now, if I kind of look at this, I can see that these are supplementary, meaning they add up to 180. And so I can say 180 minus 59. That's going to give us 10 minus 1 is 1, 20, so 121. Okay, so I could take my patty paper, my tracing paper. I can see that this one's 59. I can see this one's 121, and I can literally just move it down and see that angle F is 120, one right there, okay? Now, enter only the measure without degrees in the box. I am not going to put that little degree symbol, like there. Yeah, hopefully that was on there. Let's do it again in case it wasn't. Angle A is 59. I do my subtraction right here to get that as 121, and then I trace it, and then I move it directly down to F to see that it is 121 as well, right there. Okay, so after this, I'm going to distribute first. Negative 5 here, that's going to give us negative 15x plus 35 equals negative 10. Subtract 35 on both sides. I end up with negative 15x equals negative 45. I'll divide by negative 15, and I'll get x is a positive 3. Enter only your value, so do not do this. Just put the number. Okay. Sorry, it's been a little out of focus. Select the two figures that can't be rigid transformations of each other. I can see that these kind of look like reflections of each other, but this one's too tall, right? So A and D aren't going to work. And B and C are actually way, kind of skinnier, I guess, or shorter, right? But they're congruent to each other. So it's just going to be B and C. There you go.